defrost control board for a heat pump, which actually allows the heat pump to go into defrost mode, and it will actually begin to melt the coils off when it goes into defrost mode. The fan, which is the fan terminal over here, will stop. And it technically, it may go into, I'm not certain on this, maybe sort of like air conditioning mode. So the coils get hot, the refrigerant starts to get hot, and then the only difference is that the fan does not come on, so it doesn't allow more cold air to circulate over it. But the terminals here is on this, there's sundry different terminals, but this particular terminal here is the reversing valve. And this is Rheem and Rudd may do things a little bit differently, but I'm not certain on the reversing valve. But it may be positioned in one area and another one, the way a lot of manufacturers do it on the R wire. Some of them, like the Rheem and the Rudd, may perhaps do it on the brown wire. I'm not certain on that. But if we look here, we can see that we have RV. This would indicate a reversing valve. So, and then the B going out. So I'm assuming that this would be the B terminal here, a B wire here going to the reversing valve. Now, one thing to be aware of here, notice the C. Almost all these functions we have, whether we have a relay, whether we have whatever, they have a C terminal. You have a hot, so I'm assuming like a hot, and then a common terminal, like on irrigation system. Say, for instance, if you have 4 valves, you may have 4 hots and then a common tied to each one. And as we noticed over here where the common goes out, it comes back through. So we here, this goes out to the reversing valve. The common would go to the reversing valve. That's one particular unit. So RV, perhaps reversing valve. B dash out, perhaps that may be a brown wire going out and a common wire, and whatever color one wants to use. I'm assuming, in my opinion, it may be good to keep it blue, but whatever the reversing valve, if the reversing valve has a wire attached onto it, you just use that, whatever your common wire may be. So it's again, RV reversing valve, C. So just keep in mind that many manufacturers use the O for the orange wire for the reversing valve, and it may be the reversing valve may be it may be the same, similar, or close to being the same. However, it may be on one side or the other, and it depends on how this is energized or not energized or whatever it does. The experts can add that to the comment. But simply, the reversing valve actually just changes the flow of refrigerant. Say outside, if you go out in the summertime, when you go out and place your hand, say, a foot above the fan over there, you feel that heat. Well, the reversing valve would take that heat and put that heat inside, so your inside would act like I'm assuming maybe a condenser perhaps, and the outside would act like a evaporator. So it would just reverse. Just think of a reversing valve as 180 degrees. So that heat, what they're doing is supposedly saving you money by using the refrigerant to heat your house. However, when the temperature gets to a certain degree and gets too low, it may suffer, and so then the heat strips come on. So do keep in mind, when the heat strips come on, your power bill may get extremely high. So if you notice in December, January, February, your power bill spikes if you have a heat pump. And so this may be the reason your heat strips may be lighting up. When you go into defrost mode, it also may send a signal to light up your heat strips. So if your heat strips begin to light up, they're like a coil, whether it be a 5K 8K, 10K, whatever kilowatt it is, the higher, the more energy it's going to use. So this is just how a heat pump works. A gas furnace kind of has a different theory, but it's so just keep in mind when this thing goes into defrost mode, and when your heat strips light up, your power bill may get higher. So, and that's essentially, and when you go into defrost, this allows this to happen. But this reversing valve will allow the refrigerant, the heat from the refrigerant, to come inside. So you're at some point with a heat pump, you're using the refrigerant to heat your house, the hot refrigerant, as in the summertime when you go outside. So it just, when you think of a reversing valve, just think of 180 degrees. The inside becomes the outside, and vice versa. So it's just a 100-degree flip-flop. It's a little bit technology and a little bit cumbersome. So thank you for watching, and have a wonderful day.